this tutorial, I'm gonna talk about like half an hour, but we're gonna solve 10 Leetcode problems. First of all, I'm gonna talk about some patterns from the first 10 Leetcode problems. Yeah, so for the first 10 Leetcode problems, it's gonna be a lot of famous patterns. So for example, we have the hash table, two pointers, binary search, and dynamic programming problem. Yeah. And for Leetcode, and if we are familiar with Leetcode, we should know that Leetcode is just an online platform for developers to sharpen their coding skills. So basically, it is the one of the most famous platforms for interview. And for solving Leetcode problems, we need to understand the basic patterns, and then we can directly use the patterns to solve the problems. Of course, there are going to be some algorithmic challenges problems. That means some of the problems are going to be really hard. So that is why we need to understand the patterns, and then we're going to use the patterns directly to solve the problem. Yeah. So for preparing the interview, so Leetcode is a really famous platform for us to prepare, because the problems are basically fit for an interview. The descriptions is not so long, and the problems are not so hard compared to competitive programming. So currently, because the development of the AI, and definitely there's no possibility to take an online interview. So basically, the take-home exams will not exist, because everyone can use AI tools, large language models, to solve Leetcode problems. But for this tutorial, it is just to learn some patterns, and we're gonna solve the problem by ourselves. So normally for most of the tech interviews, it will be like a pair programming. Even you are trying to solve the problem online, so there's another, the interviewer will be online with you. Definitely there's no possibility for cheating. So for the first 10 Leetcode problems, there are the problems are like two sums. So basically we're gonna use a hash table to solve the problems. We need to find two indices in an array, and those two numbers are gonna be sum up to target. So basically for this problem, we're gonna use a hash table. The time complexity is gonna be O(n). So this is actually a pattern. So hash table is a lookup table. So this is the first pattern. And there are also some problems like add two numbers. So basically we need to know what is a linked list. So this is the very basic data structure. And there are also some other problems like longest substring. We need to find the longest substring without repeating characters. So for this problem, we're going to use the sliding window. So this is a basic algorithmic pattern for sliding windows. So basically it is a O(n) time complexity. For the fourth problem, it is a median of two sorted arrays. So for this problem, it's going to be really hard. Even though it is a binary search problem, the time complexity is going to be log(n), but it's going to be a really hard problem. It is much harder than other Leetcode problems. Yeah, and for the problem palindromic-substring, so there are two ways. Basically, the dynamic programming is a little bit harder, but two pointers is much easier. So for this tutorial, we're gonna use two pointers to solve the problem. And there's also zigzag conversion, and we're gonna use the bucket sort to solve the problems. So this is also a famous algorithm. And for reverse string, basically it is a mathematics skills. And string to integers, it is some string to integer calculation. The time complexity is gonna be O(n). It is just we just need to learn how to pass the string and turn the string to integer. And the palindrome number, this is a very easy problem. We just need to check a number if it is a palindrome. So the time complexity is going to be log(n). And the last one is going to be regular expression matching. So this is going to be a hard problem. So for the regular express matching problem and median of two sorted arrays are gonna be two hard problems, and those two hard problems are gonna be much harder than other Leetcode problems. Yeah, after solving easy and medium problems, we gotta try to solve some hard Leetcode problems, but those two hard problems are gonna be much harder than others. But it is a very good pattern for us to learn what is the binary search and what is the dynamic programming. And for binary search, normally we're gonna use the binary search to search one sorted array, but for this problem, we're gonna use the binary search to search two sorted arrays. So this is why it is hard. And for this one, regular expression metric, so we're going to use dynamic programming, but for the easy pattern is that we're going to use DFS with memorization to solve the problem. This is going to become easier compared to real dynamic programming. So let's just go over about all those problems. So for the first one, two sum. So for the two sum, we're going to use a linear time complexity to solve the problem. So for the linear time complexity, it is ON. And for the hash table, basically, it is just a lookup table. So for lookup table, we just needed to use O1 time for each of the lookups. That is why the time complexity is going to become ON. And for add two numbers, actually, we are giving two linked lists. We just needed to understand what is going to be a linked list, and we're going to use a carry. Because for two numbers, if it is 4 and 6, so 4 and 6 are going to become 10, and that one gonna become a carry. So that is why we're going to prepare a carry. I'm going to explain later in my coding. And for longest substring without repeating characters, so for this one we're going to use a hash table, and the pattern is the sliding window pattern. We're going to use the sliding window. The sliding window is basically ON time complexity. And for the fourth problem, median of two sorted arrays, so this is going to be a little bit hard. As I said before, we're going to use the binary search. So the idea is that we have two arrays, two sorted arrays. The first one is like 3, 5, and 8. The second one is 1, 4, 6, 9, 11, and 13. We cannot use the binary search to sort two arrays at the same time, but we can use the binary search to sort one array. So for example, we're going to search the first array. So this is going to be array A. And we just need to find the border for this array A and this array B. And from the left side, all the numbers from the left side are going to be smaller than all the numbers from the right side. So let me find where it is. Maybe we're going to find up. I cannot draw. Okay, I cannot draw it, but I'm gonna explain a little bit later. So for this 3, 5, here is a border, and for this 1, 4, 6, so this 1, 4, 6, 9, maybe here is a border. Yeah, we just need to find borders. All the numbers from the left side are gonna be smaller than all the numbers from the right side, and then we can find the median. And for the fifth problem, it's gonna be longest palindromic substring. As I said before, I'm going to use the two borders to solve the problem. Basically, it's going to separate from the middle. For example, I have this character C, and I'm going to separate it. For this B and this B, it is equal, and for this A and A, it is equal. So the longest is 5. And for this one, I'm going to separate two letters at the same time, because it can be even. So this is C and this C equal, this B and this B equal, this A and A equal. So the longest is going to be 6. And for the sixth problem, it's going to be zigzag conversion. Because we are giving a pattern, it is a zigzag pattern. But for the output, it's going to be I cannot draw it, but I'm going to draw it later. But for the output, we need to produce a string. Actually, the bucket sort is going to be really easy to solve this problem. For reverse integer, we are giving integers, and we just need to reverse it. Which we know it's going to have negative integers, and it's going to have overflow problem. We need to solve that. And for the eighth problem, it's going to be string-to-integer. So this is just the basic pattern, but we cannot use a library to solve it. We just need to handle some strings. Just need to turn the string to the integer. At the same time, we need to put it inside the range according to the problem. And for the ninth problem, it's going to be a palindrome number. We just need to check if this number is a palindrome. So for example, 121, it is a palindrome number. So this is going to be an easy problem. And for the last problem, it's going to be regular expressive matching. As I said before, it's going to be a dynamic programming, but we're going to use the DFS with memorization. It's going to be much easier to understand. And for all those problems, as we can see, the time complexity is going to be O(n). If it is O(n), it's going to be a linear time complexity. Normally, this time complexity is going to be good. But another time complexity like log n, it's going to be much better. As we can see, there are some log n time complexity problems. And some other problems are going to be, we're going to call it nonlinear problems. It's going to be square or cubic. So for this one, it is the square, O(n) square. But for the square, normally the problem is going to be dynamic programming. As we can see, this problem, regular expressive method, can be solved by dynamic programming. The longest palindrome, it can be solved by dynamic programming. Normally, those kind of problems are going to be dynamic programming. So definitely, for problem, we need to choose what kind of time complexity we're going to solve. For some time complexity, then we might think which kind of pattern we're going to use to solve the problem. Definitely, we need the time and space analysis. Normally, space should be no problem, but for the time complexity, we need to analyze the time complexity. Because sometimes it's going to be time limit exceeded. We have to meet the condition. And also, for a lot of Leetcode problems, we need to analyze the edge cases. Sometimes it can have an early exit. So for Leetcode problem 1. If we find it, we're going to return immediately. It means it is an early exit, but it is okay. But for some time, it's going to have the overflow problem. We need to handle the overflow or the edge cases. We need to handle the edge cases. So for this Leetcode problem, I think it is the Leetcode problem 7. We need to handle the overflow cases. So for the pattern, as we can see, hash table is also a pattern, and the linked list is hash table and the linked list is just the data structure. And for the sliding window, it is about algorithm, and two pointers, it is the algorithm, and binary search, we're going to use algorithm. And for the bucket sort, it is also the algorithm problem. And for math and string, it is just the basic mathematical and string handling problem. And for dynamic programming, basically it's a mathematical problem, but it's going to be really hard. So the approach to solving the problem is going to be, first of all, we're going to analyze the problem, and then we're going to recognize the pattern, and then we're going to select the data structure or algorithm. After that, we're going to just implement such kind of a strategy. After that, we're going to test and optimize the problem. And after solving the problem, we need to find some key insights. We need to understand the pattern, what kind of pattern we use, and can we improve this kind of a pattern. So definitely we need more practice to improve our problem solving skills. So there's a lot of things actually, but I think basically that's all about it. So now let's just start coding to solve all those patterns. So now we're gonna solve the problem one by one. At the same time, I'm gonna analyze why we're gonna use this method and why it is better. So basically, for my method, I've already found the most efficient way to solve the problem. So for the first one, to sum, we're gonna use O(n) to solve the problems. In order to make it O(n) time complexity, we're gonna use a hash table. So in Python, we need to enumerate all the numbers from the nums, and the result are gonna be the target minus this number. We just need to check if this number is inside of the dictionary, and we just need to return the two indices. Otherwise, we're gonna put it inside. So now let's just test and submit it just to prove it's gonna work. Yeah, as you can see, it works and it's pretty fast. So this is why we're gonna use hash table, because we can reduce the time. So normally if you use brute force, it's gonna be O(n) squared, but currently it is just O(n) times complexity, because the hash table is just a lookup table, and for each number of the lookup, the time complexity is only O1. That is why we're gonna use the hash table to solve the problem. Yeah. For the second one, it is add two numbers, but those two numbers are gonna represent it as a linked list. So for such kind of problems, because we're gonna add up two numbers and we're gonna represent as a linked list, normally we're gonna prepare a dummy node. Yeah, it's gonna make the problem a little bit easier. So at the same time, we're gonna prepare a carry, because 4 plus 6 can have a carry of 1. Yeah, now let's just start coding. We're gonna check if there's L1 or L2 or the carry is not 0, and we're gonna prepare a value. So the value is gonna be carry plus L1 if L1 dot value. If L1, else it's gonna be 0. And similarly for L2 dot value, if L2, else it's gonna be 0. Yeah. Now we need to check the list L1 and L2. If L1, so we're gonna update L1 to L1 dot next. If L2, so L2 gonna equal to L2 dot next. Now we're gonna update the carry, and I'm gonna prepare a digit. Yeah, we're gonna use div mode, because I think div mode is better. It can save two lines of code. Yeah, normally we're gonna write 2 lines of code, but by using div mode we can make it 1 line. Like division and modular, just use a method of div mode in Python. So the value gonna div mode with the number 10. So after that, we're gonna have a carry and we're gonna have a digit. This is exactly what we need. So the p.next is gonna be this digit. And as we already have this carry, so we don't need to handle the carry, and we just need to update the pointer of p. P gonna equal to p.next, and after that we need to return dummy.next. Yeah. Now let me just submit it to check if it works. Yeah, as you can see, it works. So the time complexity for this problem is gonna be O(n). Basically, it is O(n) plus n, but it is the linear time complexity. Basically, it is the number of nodes for L1 and L2. So it is the linear time complexity. Now let's try to solve the third problem. So the longest substring without repeating characters. So for this problem, we're gonna use hash table, because this is the most efficient way to solve the problem. Actually, it's gonna be a sliding window problem. Yeah. So we're gonna prepare the left index, result, and the hash table. So the left index is gonna be starting from 0, and the result is gonna be starting from 0 as well. Now we just need to check character one by one. So for RC in enumerate the string, and we need to check this character. If it is inside the hash table, we need to update the left pointer. So it's gonna be the maxed DL, maxed L with DC plus 1. After that, we're gonna update the final result. Yeah. So after updating the final result, we need to store the character at the index. So the index is gonna be R. After that, we need to return the result. Yeah. So let me explain a little bit about why we're gonna use the max L with the DC plus 1 instead of why we cannot use the DC plus 1 directly. Yeah. Because it's gonna have some repeating characters. So for example, A, B, B, A. What about we have a string like A, B, B, A? So for this A and B, it is okay. So the longest substring gonna be 2. What about this B? So it's gonna become 1. But what about this A? So if we are looking for this A, so the index for this A is 0, 1, 2, 3. So this is 0, 1, 2, 3. But DC plus 1, DC is D capital A plus 1, gonna become 1, right? Yeah, because DC is D, this capital is 0, 0 plus 1 it is 1. 3 minus 1 plus 1 is gonna be 3, but actually it's gonna be 2 because it can be BA, but not BBA because there's a duplicate. So this is why we're gonna use the max of L and DC plus 1 to remove all the duplicate, because definitely A is not a duplicate because currently we are checking this A, but we cannot avoid in between it may have some duplicate. This is why we're going to use max. This means we've already checked the duplicate before. Now let me just submit it to prove that it works. Yeah, as you can see it works and it's pretty fast and the time complexity is ON. Yeah. Now we're gonna solve the fourth problem. This problem is gonna be a little bit harder. So we're gonna use a binary search for two sorted arrays. For our definition, we're gonna always prepare nums1 as the shorter array, nums2 as the longer array. So if nums1 is longer, so we're gonna swap nums1 with nums2. Yeah. So the idea is that, for example, this is gonna be num A, and this gonna be array A, and this gonna be array B. And for this array A, we're gonna use a binary search to find where it is. So for example, from here we can find a border, and from here we find a border, and this side we're gonna call it left A, and this side we're gonna call it right A, and this side we're gonna call it left B, and this side we're gonna call it right B. Yeah. So the idea is that all the numbers at the LA and LB gonna be smaller than all the numbers from the RA and RB. Yeah, we just need to find such borders. If we can find such borders, the problem is going to be really easy to solve. Yeah, so we need to decide this LA and LB. The length of LA plus the length of LB gonna always be smaller and equal to RA and plus RB. Yeah, so they're going to be a little bit mathematical skills to solve. So for a binary search problem, first of all, we need to find the midpoint. So for example, here we find, so the midpoint is going to be M1, as the index is going to be starting from 0, so how many numbers? So this M1 is included for this LA left part of array A. Yeah. So this means from the left side, it's going to be M1 plus 1 numbers, and for this LB, similarly, it's going to be, this is going to be M2 plus 1 numbers. So M1 plus 1 plus M2 plus 1 gonna equal to half. It means the total plus total divided by 2. It's gonna be the half of the numbers. Basically, we need to find the midpoint. It's gonna be half of the numbers. So this means M1 plus M2 plus 2 gonna be half. So half gonna be total divided by 2. Yeah, we need to find such kind of formula to solve the problem actually. So currently we have M1, so what is going to be M2? So M2 can be calculated as total divided by 2 minus M1 minus 2. Yeah, we just need to find such kind of formula, and the A gonna always be smaller than B, and then we can solve the problem. Yeah. Now let's just try to solve it in this way. Yeah, and there is a lot of boundary checking cases. I'm gonna define the M1. I'm gonna prepare a padding and leading and padding. So the leading gonna be infinity, negative infinity, nums1, and plus the positive infinity. And similarly for nums2, I'm just to prepare some paddings. It's gonna make the problem a little bit easier. Otherwise, I need to check such kind of edge cases. Yeah, so let me just copy and paste. So this is gonna be nums2. Now I want to use A and B to represent nums1 and nums2 because it is too much characters. I just want to make it simple. And it's gonna be total. This is gonna be nums1, nums2. So the total gonna be length of the nums1 plus length of the nums2. So if length A is more than length B, so I'm gonna swap that, because I will always make the array A smaller, the length of the array A gonna always smaller than length of the array B, otherwise it's gonna have a lot of edge cases. Now I'm gonna use the boundary search for array A. So length of the A minus 1. So for the boundary search, we can write the pattern. So the M1 gonna equal to L plus R divided by 2. So M2, as I calculated before, it's gonna be the total divided by 2 minus M1 and minus 2. Now I'm gonna prepare some borders: left A, right A, left B, right B. It's gonna be A M1, A M1 plus 1, and B M2, and B M2 plus 1. Now I need to check if left A is smaller and equal to right B. Yeah, because basically left A gonna always be smaller and equal to right A, so I don't need to check that. I just need to check right B. Similarly, I need to check right A gonna less than or equal to left B. Yeah. So this means I've already found the border. If I can find the border, basically I can return the result. Basically, it depended on this total. It can be even or it can be odd. So it's gonna be the maximum of the right A and right B, because they're gonna from the right side, right A plus right B gonna always be one more element than left side, or it can be equal. So this is why if it is odd, I'm gonna choose the right side. If it is odd, so this is for checking the odd. Else, it's gonna be the two sides. Yeah. So the calculation is actually, if we check the drawing, the calculation is just basically there are two numbers. So this is one number, this is another number. So this is one number, this is another number. So this number we're gonna call it left A. This number we're gonna call it right A. So this number we're gonna call it left B. This number we're gonna call it right B. If we already find it and it is even, so from the left side, those two we're gonna choose the maximum, and those two we're gonna choose the minimum, and then we're gonna divide it by 2. It's gonna be the median. So else it's gonna be the maximum from the left side, left A and left B. Plus the minimum of the right A and right B, and divided by 2. And if left A more than right B, yeah, so this means we want to find if it is okay, but if this number is too big, yeah, we find this left A is more than right B. This number is too big. We want to make it smaller. How can we make it smaller in boundary search? We just need to shift the right index. So the M gonna be R gonna be M1 minus 1. Else L gonna be M1 plus 1. Yeah. So this is all the coding. It is a lot of coding actually, but if we understand the basic idea, it should not be so difficult. Yeah. Now let me just run it to check if there's something wrong. None is not valid value for the expected return double type double. Yeah. Yeah, it's okay. Let me just print out maybe those numbers. Yeah, so this is wrong definitely. It's gonna be left B. If left A is smaller and equal to right B, left A and left b is smaller than or equal to right a. So left a, right a, left b, right b. Yeah, now let me just check. Now at least I can pass one testing case. So for this one it works, but for the first one it didn't work. It should be 2 instead of 3. So what is wrong? Yeah, it's gonna be the minimum of the 2 at the right side. Yeah, so I did it wrong. It's gonna be the minimum because at the right side for this number and this number, definitely it's gonna be the minimum. Yeah, because if it is odd, so for the right side there's gonna be one more element than the left side. So definitely we're gonna choose the smaller element. Yeah. Now let me just run it. Now as you can see it works. Now let me just submit it. Yeah, as you can see it works. And the time complexity is going to be on log a. Actually, it's going to be on this time complexity. For here, it's going to be the log minimum mn. Yeah. Now let's just continue on to solve Leetcode problem 5. So for this one, we're going to use 2 pointers to solve the problem because it is a little bit easier. So the longest palindromic substring. We're going to define a helper and left and right index. So this helper function is just to check how much we can spread from the middle for the string. So it's going to be L more than or equal to 0 and R less than n. I'm going to define n later. N going to be the length of the string, and SL equal to SR. So L minus 1, yeah, and R plus 1. Finally, we need to return the string. Now we're going to define the result and n. So the result is going to be empty string, and going to be length of the string. So this is why from here this n, we're going to define the length of the string. Yeah. And now we're going to check all the different cases. So we're going to update the result, and we're going to use the helper function. So it can be odd or it can be even. If it is even, it's going to be I and I plus 1. And we're going to use the lambda function k going to be the length. So this means we're going to compare the length, but the final result is going to be string. So finally, we're going to return the result string. Now let me just run it to check if it works and submit it. Yeah, as you can see, it passed for all testing cases, and the time complexity is going to be O(n) squared because n is 1000, so it is okay. Yeah, because this is O(n) and this is O(n). That is why O(n) squared for the time complexity. Now let's just solve Leetcode problem 6, zigzag conversion. Yeah, so the problem is that we are giving such kind of string, and actually this string is written by the zigzag pattern. So for example, this PAY and PA is going to be a zigzag. This number of rows means how many rows. So for this example, it's going to be 3 rows. Yeah. So if we put all those characters inside, all those line of character inside a bucket. For example, this is a bucket, and this is a bucket, and this is the last bucket, and then we're going to combine them together. It's going to be something like PA. Yeah, it's going to be something like PA is n, PA is n, AP, one line, another line, another line, because each line is going to be inside a bucket. Yeah, it's going to be easier. But how can we put it like that? We can define the bucket. So the rows, we're going to define empty string. So for anything in range, so how many number of rows, it means we just need how many buckets. And as it is a zigzag pattern, so we need to define the I. I means we need to find which bucket it is, and we need to define a step. Step, it means it can, this is index 0, it can be index 1 or index 2. From index 2, it can become index 1. This step is just to check. It can be +1 or -1. So I gonna be starting from 0 and the step gonna be -1. Now let's just check all those possible characters inside of the string. So those I, for the first bucket, it's gonna be starting from index 0. Yeah, we're gonna append it. Yeah, but this is for just checking for the number of those gonna be more than 1. It can be 2 or 3. It is something like zigzag. But if there's only one row, we cannot do it like that. For this example 3, we cannot do. So we have to check it first. So if numbers of those equal to 1, we need to directly return on this string. Yeah. Now the condition is for this row, if I equal to 0 or I equal to number of those -1. So this means we need to update the step from -1 times -1. It's going to become 1. Yeah. So this means from the beginning, if I equal to 0, so the step going to become 1. So it means 0 plus 1, it's going to become 1. So after that, I going to plus equal to the step. And finally, we just need to combine them together. In Python, we can use a draw. And inside, we can draw all the rows first. Draw row for r in rows. And then we can draw all the array. Yeah. Oh, I did something wrong. Yeah, so this is going to be a rows. Yeah, as you can see, it works. Now let me just submit it. As you can see, it works and it passed for all testing cases. So the time complexity is going to be ON actually. Yeah, because actually we are just checking all those strings, as we can see from the for loop. So the time complexity is going to be ON and going to be 1000. So this is a bucket sort problem. We're going to call it bucket sort because actually we just put all those characters inside of one of the buckets. So this is bucket 0, index 0, bucket 1, bucket 2. And after that, we're going to combine all those characters together. And then, as this is a nested array, we're going to combine. Yeah, first of all, we're going to turn this array into string, and then we're going to combine those strings together. It's going to be the final result. So this is why it is a bucket sort, because we put each character inside buckets. Now let's try to solve Leetcode problem 7, reverse integer. We need to be careful. So the environment does not allow you to store 64-bit integers. So this means in Python it is okay, but for other languages like Java and C++, we cannot use that. In Python it is okay, but even in Python, we should be careful that we cannot put it inside of 64-bit integers. We have to check. Yeah. So this means if it goes out of the range, we're gonna return 0. Yeah. But we have to check that for our environment we cannot fit 64-bit integers. Even in Python it can fit, but in the algorithm we have to check that. Just imagine we cannot fit it into a 64-bit integers. So that is the only hard part of the problem. Yeah. So we just need to reverse. Yeah. So 1 2 3 3 2 1, negative 1 2 3, negative 3 2 1. Yeah. 1 2 0. At 0 there's no leading 0, so it's gonna be 2 1. So from the beginning, we can define a sign. Sign gonna equal to 1 if x more than 0. Otherwise, the size is going to be -1. Or we can define it like that. Maybe -1 if x less than 0. Otherwise, we're going to define the sign as 1. So we can define the result as 0. And we can define a max integer to check if there's an overflow or not. Yeah, because if there's a negative integer, we're gonna turn this negative integer to positive integer, and then we're gonna check if it is inside the range or not. Yeah, because we're gonna turn it to a positive integer, and we're gonna check this positive integer if it is inside of the range or not. Yeah, so the maximum integer gonna be 2 to the power of 31 and minus 1. Yeah, now we're gonna check x while x. So we're gonna use another variable y to update the final result. It's gonna be result times 10 plus x divided by a modular 10. So if this value, yeah, I forget to define this x. So I'm gonna prepare the x as the absolute value of x, because this is going to be a little bit easier. Otherwise, I have to check the negative cases. So if it is a negative number, first of all, I'm going to turn it to a positive number. Yeah. If I turn it to a positive number, I'm going to reverse it. But after reverse, this positive number can go out of the range. If it goes out of the range, it means max of integer. If it goes out of the range, it means I'm going to return a 0 according to the description. Otherwise, the result gonna be equal to y. This is my result, and I'm gonna update the x, gonna be divided by 10. So finally, I'm gonna return sign times the result, because this result can be positive or negative. Yeah. Now let me just submit it to check if it works. Yeah. Now as you can see, it works and it's pretty fast, and the time complexity is just a log n, just a log this number. Yeah. So basically, log this number is going to be a really small, like 32 or 31. So at the same time, we just check all the numbers are going to fit into a 32 bit. It is not a 64 bit. Yeah, because if this number is too big, we're going to return 0 immediately. Yeah. This is why this method is better. We don't need to check from the outside. We just need to check from the inside. If this number is too big, this means it is overflow, and we're going to return 0. Yeah, you might think, what about the negative number overflow? Because we turn this negative number to a positive number, so it is okay. For a positive number, so definitely after reverse, it's going to be a positive number. We can check the overflow. For a negative number, we're going to turn this negative number to a positive number, and then we're going to check the positive number if there's an overflow. Yeah, so it is the same idea. Even for the negative number, we can still check that if there is overflow. So we're gonna return 0. Yeah, but if there's no overflow, finally we're gonna return this negative number. It always depended on this sign, positive or negative. Now let's just solve Leetcode problem 8, string to integer. For this problem, we need to directly check it from the description. As the description is really long, we just need to check it one by one. First of all, ignore any leading white space. So just ignore it. So we can strip it. The strip is just ignore it. And then we need to check the sign. It can be positive or negative. Yeah. So assuming positivity, if neither present. If there's no plus or minus sign, so this number is going to be a positive number. So this is just the description. Yeah. So let's just prepare a sign. Going to be -1 if s0, because after strip, this string can become empty. So if not s, if it is empty, so we're going to return 0, because for here, if there's no digits, we're going to return a 0. So this sign is just to check if it is a positive or negative integer. If s0 equal to a negative sign, it's going to be a -1. Otherwise, it's going to be 1. This is for the sign. And then we can prepare this s. Yeah, so this is just some pre-processing according to the description, just to make the problem a little bit easier for solve. If s0 inside, if it is a sign, so we just strip it. Yeah, we just remove the sign, because the sign is basically not used for mathematical calculation. So we just remove it. because we've already prepared this side variable. If it is inside, else we're gonna directly use the string s. Now we're gonna check each character inside of the string s. If not, c dot is digit. If it is not digit, we're gonna break it. Otherwise, we're gonna accumulate it. Yeah. So we're gonna prepare a result. So the result gonna be starting from 0. Yeah. So result gonna be equal to result times 10 plus the integer of this character. Basically, this character is a digit. Finally, it should be inside the bounds, minimum and maximum. So it's going to be the maximum of 2 times 2 to the power of 31 to the minimum of sign times the result with 2 to the power of 31 minus 1. Okay. Now let me just run it to check if it works. Now let me just submit it. As you can see, it passed for all testing cases, and I think the speed is okay, the time complexity is ON. And we just needed to check the strings one by one. Yeah, it is 200, so this is okay. What's next? Yeah, next is Leetcode problem 9, Palindrome Number. So this is going to be a easy problem. So for the easy problem, let's just solve it directly. If this is a negative number, definitely it's going to be a false. Otherwise, it's going to be a positive number. We're going to prepare a region equal to x and a result equal to 0. And then we're going to check it one by one. We're going to use the formula to check the reverse of this number. Finally, we just need to check if this a region equal to the result or the result equal to the origin. Let me just run it and submit it to check if it works. Yeah, as you can see, it works, and the time complexity is going to be log n. N is just this number. So as we should know that we cannot just convert the integer to string, so it means we have to solve it by using mathematical skills like this kind of a formula to reverse a number. This is going to be a better way to solve the problem. Yeah. Now let's just try to solve the last problem, regular expression matching. Before solving the problem, we need to understand what it is. Yeah, because for this problem, the dot and the star have some meanings. So for this string s, we need to match with the pattern p. And I'm going to use some examples like AA, and A star. Is that a regular expression matching? It is, because this star means there are going to be 0 or many preceding characters of A. It can be, it means 4 A's. Yeah, so 4A equal to 4A, it is okay. So what about another case? What about this one? Because this character can only, this dot can only mean 1A, so there are 2A and 4A, definitely it is false. Yeah. So this is why we can check the examples. The first one going to be a false, so the second one going to be true, and the third one going to be true, because this AB and this is a dot, and the star means 0 or many dots, so it means it can be 2 dots, and this dot can be A and another dot can be B. Yeah. So the idea for solving the problem is that I think for other part it is just easy. So for this A and this A, we're gonna check if there's a match or not. But the difficult part is this pattern, if there's a star. Yeah. So if this is there's a star, we need to check this A and star together instead of directly check A or star, because this star means there's gonna have some relationship with the preceding A. So we need to check it together. So this means if the first character inside of the string s equal to the first character inside of the pattern p, we're gonna define a variable called match. And then for the next character for the pattern, we have to check if it is a star. If it is a star, we're gonna check them together. If it is a star, it can be empty. It means after that it may have 2 characters. We're going to compare those 2 characters with those 4 characters. Or if there's a star, we just remove this character. It means 1 or many characters. We're going to just update this I pointer to here. We're going to compare this 3a with all those ones. Yeah. If there is a star, we can compare those 2a with all those. Yeah, 2a with all those. It is also possible because this star can be empty. It means we're going to compare those 2a's and those 2a's. Yeah. Now let me just start coding. As I said before, for this problem, I'm going to use DFS. Finally, I'm going to call from index 0 and 0. So the edge case is that if I is more than or equal to length of the 3s and p more than and equal to the length of the 3 pattern, this is going to be j. Yeah, so it's going to be a true case. Otherwise, if this j is more than or equal to length of the pattern, but I is not, it's going to be a false. Yeah, so this means we've already consumed the pattern, but we didn't find it. It's gonna be something like a b b, and this is gonna be a star. Yeah, so this is the pattern. This is the string, and we've already consumed the pattern, and this a is consumed. But here, this string goes out of the range. But for s, the I is just here. Yeah, so this means they are not equal. It's gonna be a false. Now we're gonna find the previous characters. We're gonna call it math. So math gonna equal to if I less than 3s and si equal to pj, or pj equal to dot. So this is the easy part. We just need to check for current character if it is a match or not. Yeah. Now we're gonna check the pattern of star. If j plus 1 less than the length of the pattern, and the pattern j plus 1 equal to a star. Yeah. So if it is a star, there are going to be 2 cases, and if it is a match, it's going to be with match and DFS with I plus 1. Yeah, so if it is a match, we can use 1 or many characters, so it's going to be I plus 1 and j. Otherwise, it doesn't matter if it is a match or not. We will use 0 characters. So I gonna be still from the beginning, but j gonna plus 2. So finally, if there's no star, we're gonna check current. If it is a currentless character, if it is a match. And what about the next one? It's going to be I plus 1 and j plus 1. Yeah. Now let me just run it and submit it to check if it works. Yeah, as you can see, it works. And the speed is okay. The time complexity is O(n squared). So this is by using DFS with memorization to make the problem a little bit easier. Yeah. Now let's just go back what we have checked before. Yeah. So as we have this space and time complexity for a problem, normally the space is okay, but for most of the time we need to analyze the time complexity. But there's also a trade-off with time and space. Yeah, and there's also some edge cases. And for the first 10 Leetcode problems, actually we know some hash table how to solve by using hash table linked list, a sliding window, 2 pointers, bucket sort, boundary search, dynamic programming, and some mathematical skills and string handling problems. Yeah, actually those 10 problems is a lot of patterns inside. And we analyze how to approach for a problem. Yeah, so basically each of the problem is not so easy. We have to find the pattern and use the pattern to solve the problem. Yeah. And after solving those problems, actually there are other similar problems for us to solve. So this means after solving that 10 problems, you may use those patterns to solve like more than 100 problems. So for the 2 sum, we can use the similar idea, like the 3 sum, 4 sum, even though it is 2 pointers, like the 2 sum 2. And for the string problem, we can use the longest string with k distinct characters, or wildcard palindrome, or balanced processes. A lot of similar patterns, actually. Yeah. So I think that's all about it. The next step is that I'm going to prepare the next 10 Leetcode problems. It's going to be Leetcode from Leetcode problem 11 to 20 or 21 to 30, but basically I'm going to prepare such kind of patterns. Basically we need to practice more to understand more about those patterns. Yeah, I think that's all about it. Thanks for watching. See you next time.